All right, so we have spent some time talking about exponential functions where we have our variable and the exponent. And then we talked about logarithmic functions, which is a form of an exponent and it's the inverse of the exponential function. And we talked about base 10, which is a common base, or the log, without any base value on it. Today we're going to spend some time learning about something called the natural base. And the natural base deals with the number e. Yes, I said number e, not letter e. E is a transcendental number. It's going to go on forever, non-repeating, no patterns, just like pi does. So we are going to spend some time understanding the value of e using notation with a base of e and using what we call the natural log. Again, common log is base 10, natural log is base e. So the natural base, meaning it was born to be a base, it's in its nature, is the number e. So our number e starts with 1 plus 1 over n to the nth power. So I want you to take a minute and with your calculator, I want you to evaluate this when n is 1, when n is 10, when n is 1,000, and when n is 10,000. So what I mean by that is if you go to your calculator, if I did this when n is 1, I would say, okay, I want 1 plus 1 over n is 1, close parentheses, to the first power, because n was 1. And I end up with 2. So then the next thing, go ahead and do the same thing, except plug in 10, then plug in 1,000, plug in 10,000. So pause your video, go ahead and find those values for me. All right, so hopefully your calculator screens look like this, and we ended up with 2.593, 2.704, and 2.716. So this is only when n is equal to 1,000. If I go out to 10,000, all to the 10,000th power. It's a lot of power. Remember your superpower question. Oh, that's when if I was live teaching, you guys would all yell at me and say, Ms. Schwartz, you typed in a division sign instead of an addition sign. And I would say, I know, teachers make mistakes too. There we go. 2.718, and that is our magic number e. E is really what happens when you take the limit as n goes to infinity. So as n is going to get really, 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 really big, e converges on the number 2.718. Okay, so kind of like you learned that pi was 3.14. You want to keep in your head that e is a base of 2.718. So using that, we have e as our base, again, 2.718. It says evaluate for x equals 2 and then x equals 1.9. Well, for x equals 2, that means f of 2, and we get e squared plus 1. That's actually an okay answer. We can leave it just like that. If I did f of 1.9, that would be e to the 1.9 plus 1. Again, these are okay answers. If I wanted to, though, I could use my calculator, and there's two places you'll find e. The first is right here. It's a little blue e to the x, so I can type in e to the second plus 1, and I get 8.389. Okay, so doing that again, I can go second e raised to the 1.9. And I get 7.686. So this next one looks a lot more complicated, but similar process. We're going to find g of 2. So negative 3 e to the 4 minus 3, which is really negative 3 e to the first, which is really just negative 3 e. Then I can find g of 1.9, which is negative 3 e to the 3.8 minus 3, which is negative 3 e to the 0.8. And again, I could use my calculator and I could get some decimal approximations. So let me move this out of the way a little bit. Negative 3, here's the other place that e exists above the division sign. That's if you just want good old e without the exponent on it. So we're going to get negative 8.155 And then I can also do negative 3e, this time I want to raise it to the 0.8, and I get negative 6.677. And these are, again, decimal approximations, but you can leave your answer in terms of e. Just like in geometry class, we left things with pi, and when we were working with radians, we definitely had things in answers of pi. All right, so we have our natural exponential function because its base is e, which means that we have a natural logarithmic function that is log with a base e. Yes, you can write it this way. So we've seen, log base 2, log base 3, log base 4, log base 10, where you don't have anything written there. But mathematicians tend to note the natural logarithmic function with the ln, and you'll often see me write ln, that's lm, ln, just to get a little cursive in there so that my lowercase l doesn't look like a 1. But ln is natural log. I understand you think it should be nl, natural log, but it is what it is. It's a mathematical notation thing. It really just means log with a base e, which means you're asking yourself that question, e, 2.718, to what power gives me y? It's that what power question that we are still working with. All right, so properties of the natural log. We're going to have the natural log of 1 is 0 because e to the 0 power gives me 1. The natural log of e is going to be 1, and that's because e to the 1 power gives me e, right? We're assuming there's this little e here. So e to the first gives me e, and e to the 0 gives me 1. The natural log and the natural exponential function are going to be inverses and cancel each other out, and we are left just with x. Exponential base and a logarithm in the exponent, those are going to cancel as inverses. We're also left with x. And just like before, if the natural log of x is equal to the natural log of y, then whatever is inside of that function, those two values must be equal. All right, rewrite the log equations as exponential functions. So an exponential function needs to have a base and then something raised to a power. So here, again, we're saying e is our base, raised to the 1.386294 will be equal to 4. Here then, natural log has a base of e, which means e to the negative 0.470036 is going to be equal to 5/8. So we're rewriting them in exponential notation. All right, so here we need to rewrite these as log equations. So thinking about how I could undo this, that means that negative 4, my power, is equal to the natural log of 0.0183156, because if I go backwards, e raised to the negative 4 gets me back to 0.0183156. So again, I'm thinking about this what power, right? Logarithms is what power. 3/4 was the power, and that's equal to a log base e, or the natural log, of 2.117000. I just told you I would write in cursive for your sake, and I didn't actually do it. Please forgive me. And now you can check these in your calculator. So if I go to my calculator and I type in the natural log, which is this button right here, conveniently located right by that e to the x, the natural log of 4 is in fact 1.386294. And then if I do e raised to that power, I get 4. An exponential and a logarithm are inverse operations in the same way that if you multiply something by 3 and immediately divide it by 3, you're right back to where you started. Right? It's that inverse concept of f inverse is equal to x, f inverse of f is equal to x. So thinking about tying a shoe and then retying a shoe, we've talked about that before in class with inverse functions. So the last thing I want to go back to, again, is just this notation, that anytime you see ln, it is understood that what you're talking about is a log base e. So when you need to do the switch around, we're talking e to what power is equal to y.